construct RLC circuit which is underdamped, overdamped, and critically damped cases using software multisim. For underdamped, it is alpha less than omega naught. For critically damped, it is alpha equal to omega naught. For overdamped, it is alpha bigger than omega naught. Now, we want to show the simulation. Firstly, we open project circuit simulation at the multisim software. So, for underdamped circuit value, which is 30 volt for voltage, resistance R1 equal to 2 ohm, R2 equal to 8 ohm, inductance equal to 1 Henry, and capacitor is equal to 0.25 farad. To stimulate the initial value I0 and V0, just put the current probe after resistance R1 and differential voltage probe at the both capacitance pin. So, the underdamped, we got initial value I0 is 3 ampere and V0 is 24 ampere. To simulate the graph response, just put the voltage probe at the inductance and capacitance pin. Then, insert the initial condition value at the inductor and capacitor. Click the Stimulate, then go to Analysis and Simulation. Then go to Transient. To set the time at the analysis parameter, and go to the output at VPR2, VPR3 and V1. Then we click Save and Run. So this is the underdamped graph. Blue line is voltage source graph and green line is underdamped graph.
For overdamped, it is alpha larger than omega naught using the value which is voltage is 30 volt, resistance R1 is 2 ohm, R2 is 0.5 ohm, inductance is 1 Henry, and capacitance is 0.25 farad. To simulate the initial value of I0 and V0, the step is same as the underdamped. So, to overdamp, we got 12 ampere for I0 and 6 volt for V0. To simulate the circuit of overdamp, also the step is same as underdamp, but we change the initial value at inductance and capacitance, which is 12 ampere and 6 volts. So, we click the simulation button to simulate the graph. The blue line is the voltage source graph and the green line is the overdamped graph.
Next, the critically damped, it is alpha equals to omega naught using the value which is voltage 30 volt, resistance R1 is 2 ohm, R2 is 2 ohm, inductance is 1 Henry and capacitance is 0.25 farad. To simulate the initial value of I naught and V naught, the step same as the under them. So, to critically damp, we got 7.5 ampere and to V naught is 50 volt. To simulate the circuit of critically damped, also the step same as under damped, but we change the initial condition value at inductance and capacitance, which is 7.5 ampere and 15 volt. So we click button run to simulate the graph. The blue graph is voltage source graph and the green line is the critically graph. So here we are. Thank you.
For case study, RLC circuit may be used as smoothing circuit. So, for the get the smoothing circuit, our group choose a piece pie design for the circuit. First step, open the piece pie and click the button circuit schematic. And this is our design. This is VS is input, resistor, inductor, capacitor and ground. And click the VS for the output voltage 1 is 0, voltage 2 4, voltage 4 10, voltage 5 10, voltage 6 negative 2, V7 negative 2 and V8 0, and click the save and OK. Next, click the button simulation and we can see based on the design we get the graph, and the graph line green is staircase based on the circuit, and the red graph as a smoothing circuit. For the different staircase function, step for the second staircase same like staircase 1, but we change the VS as input like V1 0, V2 6, V3 6, V4 30, V5 30, V6 negative 3, V7 negative 3 and V8 0, and save and OK. Next, click the button simulation. Okay, we can get the result like graph red staircase and line green is smoothing circuit. Before smoothing circuit 1, we can see different starting and point end. Okay. The smoothing circuit, we change the VS in V1 0, V2 4, V3 4, V4 14, V5 14, V6 negative 2, V7 negative 2, and V8 0. Save and OK. And click the button simulation. Okay, we can see different from the staircase. Because we using 40 volt and using negative 2 for the input, and smoothie circuit can be see like the end and start